Hello everybody and welcome to this video on Dunder methods in Python. So these are methods that allow instances of a class to interact with built-in functions and operators. Dunder just meaning double underscore because the methods themselves are defined with a double underscore at the start and a double underscore at the end. And this is the init Dunder method, which is commonly used in object-oriented programming. You might have seen it before, and we're going to go over it in a bit of detail in a little bit. But to start off with, we've got this inventory class, and what we want to do is we want to create some objects from the class. And you can see that we've defined some attributes here. So we've got the weight, color, and price of an object, an instance of this inventory class. So let's create those instances. So we've got a camera here, which is 400 grams, grey colour and priced at £500. And then we've got the water bottle, which is 18 grams, the colour blue and priced at £1. So we might want to do something where we print an object, we print the camera here, and what you'd expect back from this is a nice human readable string where it says the camera is 400 grams, it's got the color grey, and it's £500. That would be the ideal scenario. But when we actually print this object, you can see that we don't actually get that back. Instead, we get this string, and the reason why we get this is we haven't told Python how to represent this object as a string, so it just returns this default behavior that includes the location of the object in memory, which isn't ideal. So what we want to do is we want to tell Python how to convert our object that we've created from our class to a string. And the way that we can do that is using a Dunder method. But before we do the Dunder method, I would just like to say and point out, you could potentially do something like this, where you had an F string and you actually just defined how you want the string to be printed out already. And that is valid, and that would give back the correct sort of response that we're looking for, a nice human readable string. But the problem is we'd have to define that F string every single time we want to print an object out, which isn't ideal. Instead, we can use the str dunder method, which makes it a little bit more straightforward. We could do something like this, where we define how our object is dealt with as a string, and when we use the print method, this is what it returns. So it's a better way of dealing with it, because now we can go ahead and print whatever objects we want from this inventory class, and we can see that we get back a nice human readable string. So this is why Dunder methods are particularly useful. They allow instances of a class, in this case the camera and water bottle objects, to interact with built-in functions and operators, in this case interacting with the print function, the built-in print function, which when ran converts the object to a string. And you can see now that we're converting the object to a string, we're getting it in a nice format because we've defined how our object should be converted to a string, if that makes sense. So that's one particularly useful Dunder method, and it's usually paired alongside this method as well, this Dunder method, which is a different type of version, but it's used mostly for debugging, and it's more of a developer way of seeing how objects are compared to the string Dunder method. And these two are usually paired together. We can then have a look at potentially using other Dunder methods as well to see how we can improve how the objects interact with different operators. So you could have, say we have these two objects here, and they want to interact with the plus operator. If we run that code, we're going to get an error just because the operand isn't supported. The plus operator isn't supported for the operands. The operands being the left-hand side and the right-hand side of the string, which is our two objects. They don't support using the plus operator. So what we could do is use that Dunder method, something like this, the add Dunder method, and then that describes if we are adding two of our objects together, what should be returned, what should be printed out. In this case, when we add the two objects together, it's going to add their price together and then print out the total price. So we can see if we go ahead and run the code, we get the result that we want now. When we add the camera object to the water bottle object, we get the price of the two objects together, which is equal to 501. So it allows our instances of the class to interact with operators as well, which is particularly useful. And we're saying in this case, we just want to add the prices of these objects together and then return that. The if statement here is just dealing with the case where the left-hand side is an instance of the inventory class, but the right-hand side of the expression isn't an instance of the inventory class, which would cause issues, and it's just handling it in a better way. So that's what we're doing with the if statement. And we could also, this also applies to, for example, if we wanted to subtract the two objects from one another, we wouldn't be able to do this usually. If I run the code, you can see that we get an error because our operands, our objects, are unsupported for the type of the subtraction operator. So we can do something very similar where we use the Dunder method here to specify that we want to subtract the price of the left hand object from the right hand object, and we're specifying that here. And I think it's important to understand that everything in Python is an object. So the reason why you can already add strings together, for example, or add integers together, is in Python because those objects, the string object and the integer object, have already been defined with this add Dunder method. So say if you were to print 4 plus 5, you'd expect it to give 9. And we just know that that works. But what is actually happening under the hood is the integer object has been defined with this Dunder method, and we're just doing the same for our objects here so that we can add them together as well. So that's the main principle of what we're doing here. So looking back to what I was mentioning earlier about the init Dunder method, which you might have come across before, we can hopefully now understand a little bit better how this operates and why it's there, and why it's so often used in object-oriented programming. So when a new object of a class is created, it initializes the attributes, preparing them for use. So it's just another Dunder method that allows some functionality to take place on an object when a specific action, in this case, creating a new object, is performed. So if we didn't define it, then Python would still create the object, but it wouldn't automatically set any attributes for the object. So it's pretty useful and very commonly used. So let's continue to look at some other Dunder methods that we can use to improve how our objects interact with different built-in functions. So it might be the case that we want to iterate over our object. So if we run this code where we're using a for loop to try and print out all of the attributes of our camera object here, we can see that we get an error because our object isn't iterable. So we need to make it iterable, and we can do that using a Dunder method, another Dunder method, this iterator Dunder method, and what happens here is it's making the objects iterable. And when we use yield here, this function here can behave like a generator. So it means that the instance of the class then conforms to the iterator protocol and then can be looped over. So if we were to run the code again, we can see that it now works. We can iterate over the instances of our class, and we get back the attributes of the camera, that it's 400 grams gray and 500 pounds, which is great. And then finally, we might want to use the square brackets notation. So it'd be really useful if for our object, we could specify an indice with the square brackets, and it would give us back that particular attribute, or even specifying via a string that we want the weight of the camera, and then it prints back the value of the weight attribute for that object. So that would be really useful. And one way we can do that is using a different Dunder method called getItem. So in this if statement, we're just specifying if we provide an indice, how it should deal with that. And then in this section here, we're just dealing with if we provide a string as part of the square bracket, how it deals with that as well. And then we've just got some code here that deals with potential errors and handling those. So you can see how this Dunder method can be useful. And then if we were to go ahead and run the code, we can see that we get back the results we expected. And if we didn't have the Dunder method, it would throw a error saying that it wasn't subscriptable because it couldn't deal with the square brackets, whereas now it can, which is really good. So you can see that when we try and get the 0th attribute of the camera, it gives us back that value, 400 grams. And then it's the exact same if we were to specify that we want the weight attribute, that gives us back 400 as well. This getItem Dunder method just makes the instances of the class, the camera and the water bottle in this example, behave like a list where you can use the square bracket notation, which is great. And now you might be wondering, for example, okay, well, we could just do camera.weight and print that, and that would give us the exact same result. And that is correct. However, having the square bracket notation is great because you can index stuff, and also it is useful in terms of it provides another way to iterate over our object. So in this example, we're iterating over the object using the square bracket notation, and we're wanting to get just the weight and the price of the camera. And we can see if we run the code, then it gives back the weight and the price. So that's a quick look at how you can use Dunder methods in Python. Thank you for watching.